Hello, my amazing Algebra 1 students. This is Mrs. A, and I love math. Today, we're working on Lesson 14 in your Orange Book, and we're talking about evaluation of algebraic expressions. So, first of all, we need to talk about what is an algebraic expression. So, we're going to go all the way back to what is a numerical expression. So, today we're talking about algebraic expressions, but the start of your chapter will take you back to what is a numerical expression. So here we have number is an idea way back in chapter 4, and a numeral represents that idea. So if we're thinking of the number 3, okay, the 3 means 3 dots on paper or 3 sugar cubes or $3. The 3, the concept of 3, is represented by the numeral 3, which we all recognize as this. So this is the numeral 3 that represents the concept or the idea of 3. So now, if we're talking about the idea of 7, the idea of 7 could be represented by 7, or 14 divided by 2, or 4 plus 3, or negative 21 over a negative 3. Lost my negative there. Each one of those could represent 7. Okay, so these are all numerical expressions because they represent a number. And we know what the number is, and there's nothing but numerals in each one of these expressions. So we call these numerical expressions. So now, sometimes, as we get higher in math, and we're in algebra now, we use letters to represent numbers. And specifically, we let letters represent numbers that we do not know the value of, and we call these variables because they can vary or change from problem to problem. So algebraic expression has letters and numbers in it. Okay, so now here is an example of an algebraic expression. We have 4 plus x. Now 4 is a numeral, and we know its value, but x is a variable. It is a letter that stands for an unknown number, and we don't know its value. So we call this an algebraic expression. What is the value of the whole expression? I don't know until I find out what x is. So the value of the expression depends on what is the value of x. To be decided, right? So here we have the same expression, 4 plus x. We call the 4 a constant because we know its value and it stays the same. It does not change. We call the x a variable because its value can change depending on what I decide to let it be. Okay? So here are some expressions for multiplication that we use when we are dealing with numerical and algebraic multiplication. 4 times x. Because x is not a numeral, we don't have to worry about putting a little dot between them. We can, but the expression will stand on its own if it's just 4x, because 4x means 4 times x, and there's no problem with getting confused that maybe the x is a numeral. 4 times x, 4 times x, 4 times x. They all mean the same thing. That's a lot of different ways that you can write, express 4 times x in algebraic expressions. So now this one, we have an expression. And apart from what you see down here, we do not know the value of that expression because we don't know what x is. So we decide to let x be 3 and m be 5. Well, when we do that, we get 4 times 3, because x is 3, plus, and m is 5, so 5 times 3, which is 12, plus 15, which is 27. But what if I should change those values? What if I said, so the first time around, we got a 27. So we'll just put a 27 down here so we remember it, 27. I'll let my marker sit open too long. Okay, so we had 27 when we let x be 3 and m be 5, but now let's take all of that out, and we're going to, the second time around, let x be 2. We're going to let x be 2, and we're going to let m be 6. Okay, which means that we had 4x, and x is now 2, so that's going to be 4 times 2. Okay, and then we had m, which is now 6, so we're going to have to change this to a 6, and then this one is an x, and it turned into a 2. Okay, so when we go to multiply all of that together, we're going to say it is no longer 12 plus 15, is it? It is now 4 times 2 is 8, plus 6 times 2 is 12, and now the value of the expression is now 20. So I did it one time and got a 27. I did it a second time, changing my values of both x and m, and I got a 20. So the value of the algebraic expression depends upon the variables that you choose to substitute in. And that is cool. Okay, now we get to have the fun of doing some examples. Find the value of xmp. So this means that x and m and p are all multiplied together if x is 4 and m is 5 and p is 2. Now let me show you an easy and fun way to do this. If we're going to do xmp, we're going to multiply them all together. So let's go ahead and put the parentheses there for multiplication. So this one was x, and this one was m, and this one was p. So now we're going to put the values that they tell us to put in. So x is 4, so we're going to put a 4. And m is 5, so we're going to put a 5. And p is 2, and so now I'm going to multiply left to right. 4 times 5 is 20. 20 times 2 is 40. So the answer is 40. Okay, so here is the next example. And we are to evaluate, which means to find the value of 4yz minus 5. So again, we've got our values here. Let's go ahead and multiply. Let's write down the skeleton, I call it. So we're going to write down 4 times the y times the z minus the 5. And I only use my unknown numbers. I don't need to put a parenthesis for the 4 because I know what it is. And I don't need to put a parenthesis for the 5 because I know what that is. So I'm just leaving a space for my y and my z. Now y is 2 and z is 10. So now I'm ready to evaluate or find the value of my problem. 4 times 2 is 8, and 8 times 10 is 80, and 80 take away 5 is 75. And that is the answer to the second problem. As you can see, that is 14.2 in your book. Okay, so now let's look at the next one. So here we have evaluate y minus z. Here we have two unknowns, y minus z. So I'm going to put my little, I call those little cocoons. Okay, so we're going to put our little cocoons there, and we're going to substitute y as -2, and there's my y, -2, goes in that cocoon, and then z is a -6. So z is a -6, -6 goes in there. So now I have a minus a -6, which we know becomes a +6. So I end up with a -2 plus 6, and -2 plus 6 is a +4, and that is the correct answer for example 14.3. Okay, so here we go to the next example, and we are to evaluate -a minus b minus ab. Okay, so let's do our little cocoons. -a minus B minus, now I'm going to put them two cocoons together here, okay? It's as good a name as any, right? Cocoon, I like it. All right, so now we're going to plug in our A's everywhere that our A goes. So our A is here in the front, and that's a -3. And then our A is also the first one of these over here. So our A is a -3. So we put a -3 there. And our B is a -4. So our B was right here. So -4. And then again, -4 down here on the end. So I filled up all my cocoons with what's supposed to be in them. And so I've got the opposite of a -3 as a +3. So we'll just write down +3. Let's write a little spot here. +3. And then minus a -4 is a +4. And then what happens here? We have the opposite of a -3 times a -4. Well, -3 times a -4 is a +12. And the opposite of a +12 would be a -12. And 3 plus 4 is 7. And then 7 take away 12 is a -5. So we should get a -5. And that was example 14.4. Okay, so now we're looking at example 14.5. And we have 3 variables. So let's make a little cocoon. So -x minus a -a plus a b. So every variable gets its own little cocoon, and I'm going to close the end one here. So I ran out of room there. Okay, so are you ready? Let's substitute an x into the first one. So x is 2. And then this one right here is an a and then a b. So a is -4. B is -6. Now, look and let's see what our algebraic expression is now. We have only numbers in it, so we turned our algebraic expression into a numerical expression, didn't we? So what does our numerical expression now have a value of? So -2 is a -2 minus, okay, now in here is one big parenthesis. So shouldn't we do what's in that big parenthesis before we do this? So let's just copy our minus down and find out what is this big parenthesis here. Well, in this big parenthesis here, I've got a negative a -4, which is a +4, plus a -6. So all together, isn't that a -2? So we get a -2. So now I've got a -2 minus a -2, but minus a -2 is a +2. So -2 plus 2 is 0. So the answer for this one should be 0. And it is. So that was example 14.5, and we got that one correct. Okay, so now we're doing 14.6, and we have this problem right here, which they're getting a little bit longer, and they're going to get longer and more interesting. So we need a little bit of space here. So I'm going to write a is -4 right there. I'm going to take this off so we have room to put our cocoons down at the bottom. So here we have a cocoon for x minus a cocoon for y. And then right backed up to the y is a negative cocoon for a plus cocoon for x. And then we're going to close our closing parenthesis. Now, if we want to, we can always take these big parentheses here and we can turn them into brackets. And sometimes when we do that, it makes it a little bit clearer what's going on. So I'm just going to turn those big ones into brackets, because those brackets are what we use when we have parentheses inside of parentheses and we start to get confused. So now I've written just what I need, and now I have to start substituting. Let's put an x everywhere we see an x. Right at the beginning and right at the end we see that x. And x is a -2. So we put in the -2, and then way over here at the end we plug in the -2. Okay? You see, once I've got my skeleton down here, I can just plug right into those little cocoons there. Okay, so then we have a minus y, and y is a 3, so we'll put a 3 right in that cocoon. And over here, we have the negative in front, so all we have to do is take the a, which is a negative 4. All right, so now let's think about our order of operations here. When we're thinking about order of operations, let's look back at the original without all those cocoons in here. Doesn't this need to be done first? And when we're talking about order of operations, that's what we call a symbol of inclusion, isn't it? And so we need to do that first before we distribute the y through there. But if you look at this up here, it's very clear. We're going to do this. We're going to figure out what it is. Then we're going to multiply this times this. And lastly, we're going to take x minus all of that. Okay, so let's look here. We're going to have to do this part here because it's in a big bracket here. So negative a negative 4 plus a negative 2. So negative a negative 4 is a positive 4 plus a negative 2 is a positive 2. So let's get a different colored marker just because this one does not have a lot of room. Probably should have done this on a bigger board. But 4 take away 2 is a 2. So in this parenthesis now, I have a 2. And then the next thing I should do, remember, is multiply this times this. So I've got a 3 here. Remember, when I have a negative in front of a constant that I'm going to multiply through, I can either attach the negative or leave it alone. I'm going to leave it alone this time. I'm just going to figure out what 3 times 2 is. And 3 times 2 is 6. So now I've got negative 2 minus, because I didn't touch that one yet, negative 2 minus 6. So negative 2 minus 6 is negative 8. And so all of that work gave you a negative 8 on 14.6. And now we're ready to do a couple more examples, and then we're going to work on our practice. This one's a doozy, isn't it? We've got negative, and then we've got m plus x in a parenthesis, and then we have another parenthesis over there, and those parentheses are joined with multiplication. So this is exactly the way that it's supposed to be. So I have one parenthesis and then another parenthesis. And remember, parentheses are going to be addressed as we move left to right. And if we have stacked parentheses, we will do them inside out. So we don't have any stacked parentheses here. So let's go ahead and do our, make our cocoons here. So we're going to have negative, and then we're going to write, let's change our parentheses into brackets. Okay, let's make the big bracket so that we can leave our little cocoon plus our another little cocoon and put a bracket. Okay, and then we're going to have another bracket to start the next one, and then negative cocoon plus, and then cocoon times cocoon, right? Cocoon and cocoon, and I need more room, and I don't have more room. Okay, so here we have our shell of what's going to go on, our skeleton. So here we need to start substituting in. M is 2, so a 2 is going to go here and right here at the end. So there's a 2. And then we have a negative 3 as our x, and x goes here and way down there. So that's going to become a negative 3. And then way down here, where I almost have no room, is a negative 3. So that right there is a negative 3. And then a negative 4 is going to go right here for the a. So negative 4. So I made my skeleton and I filled in the cocoons. So now I'm going to look at this big bracket here. 2 plus a negative 3 is a negative 1. So that's what's going to go in that bracket. And then let's look at this one, because this one, a little part back here, is hard to read. That's a 2 times a negative 3. So let's just write this down here, a little bit easier to see. So we got a negative 4, which is a positive 4, plus, and then a 2 times a negative 3 is a negative 6. And so let's finish that one up. 4 plus a negative 6 is a negative 2. Okay, but since these are snuggled up next to each other, we've got bracket and then right next to it, bracket. That means multiplication, doesn't it? So we have this negative in the front. So we have negative 1 times negative 2. So we have a negative times a negative times a negative. That's 3 negatives. That's going to be a negative 2 for our final answer. So I'm going to let you look at that board, and negative 2 is correct. This is 14.7, okay, which is in your book, but I'm just trying to show you how to write them as easily as possible. You can see how they're doing the little skeleton just like I am, and the little cocoons. They're just not calling them skeletons and cocoons. All right? So, now let's go do the next one. Here's our last example, and then we'll work some practice problems. So we're going to have to write this down. So negative cocoon times cocoon. And then I'm going to change this parenthesis to a big bracket. And we're going to put cocoon minus cocoon, and then close it with a big bracket plus cocoon. Okay? So the brackets help if we turn those big parentheses into brackets so that we can keep things straight. So now we've only got an A and an X. So we've got to figure out and put everything in the right place. X's are 4s. So there's a 4 there, and then there's a 4 there. Those are all the 4s. And then A's are negative 2, and there's a negative 2 there, and there's a negative 2 there, and there's a negative 2 there. Okay, so now this needs to be done first, doesn't it? So that means this needs to be done first right here. Okay, so 4 minus a negative 2 is 4 plus 2, or 6. Okay, and then we've got negative 4 times a negative 2, and notice this is also a multiplication, times 6, and then lastly plus a negative 2. So we need to do all of this before we do this, because our order of operations tells us to do multiplication before addition or subtraction. So negative 4 times a negative 2 is a positive 8, times a 6 is a 48, plus a negative 2 is a 46. Okay, and 46 is the correct answer. So I hope that's helped you. Now we're going to do our practices. So I want you to pause your video and try to do the practices by yourself, okay? So what I want you to do is try to do, there's 4 practices. I want you to try to do them all by yourself. So then we'll come back and do them with me. Pause your video. I hope you paused your video. The first one we're going to do is x minus xy. Okay, and we are going to let x be negative 2 and y be 3. So there's our problem, and hopefully you've done it. If not, you need to pause it and go do it. But let's go ahead and put our skeleton up here. So we're going to have cocoon minus cocoon times cocoon. And then we're going to plug in our negative 2 for our x's here and here. Negative 2, negative 2. Our 3 for our y right here. Now, order of operations tells me I have to come back here, because this cocoon is just holding a number, not an operation that needs to be done. So negative 2 times 3 is a multiplication operation, and it needs to happen before any subtraction does. So this is going to become a negative 6. We have negative 2 minus a negative 6. Okay, so now a minus a negative 6 is the same thing as the opposite of a negative 6, which is a positive 6. So we have negative 2 plus 6 is, since they're opposite signs, we subtract and get 4 and take the positive sign. And that is your first practice problem. I hope you got the same answer. This is our next practice problem, which I hope you've already done. We have to get our skeleton going here. So we've got cocoon minus, and we're going to turn these into the big brackets here. Okay, so here we have a cocoon times another cocoon, so we'll put them close together, minus another cocoon, and then we'll finish with a bracket. So now let's go fill in our cocoons. So we have A is -4, and A is here, and A is here, and A is all the way to the end. Lots of A's. B is -2, and it just goes in one spot right there. And now we're ready to go. So let's think about it. This needs to be done first, but inside this parenthesis, doesn't this A times B need to happen first? So we're going to come here and do that first. So -4 times the -2 is a +8. So we have -4 minus, big cocoon, big bracket here, 8, and then minus a -4 is a +4, isn't it? So we have a +12 here. We end up with -4 minus 12. And -4 minus 12 is going to be a -16. Hopefully you got that one right as well. We only have 2 more examples. Okay, so here we have our next to the last problem, and we have our substitution values. So we're going to make our skeleton. We have a cocoon minus cocoon times cocoon. We're going to make this into a bracket so we can tell the difference. And then cocoon minus cocoon, and then big bracket. Okay, so all these brackets indicate that we need to do this part first. So we're going to come in here and fill in, and then we're going to do this little part first. So this one is going to be an x, and an x is a -3, and there are no more x's. We have an A is -2, goes here and then here, so -2 and -2. B is a -4, it goes here and here, so -4 and -4. So now let's do the stuff. Okay, so we come over here and we do this stuff. -2 minus a -4 is -2 plus 4, and -2 plus 4 is 2. So all of that in there is a 2. And now look what I have. Multiply and multiply. So I have 3 things. Now that I've evaluated this, and this is a 2, it's going to be this times this times this. So we're going to multiply 3 things together, and those 3 things are -2 and -4 and a +2, all multiplied together. Well, -2 times -4 is a +8, and 8 times 2 is 16. So this very complicated expression is now simplified to -3 minus a +16. Okay, so minus a +16 is the same thing as a -16. Okay, because that minus could be attached or left there. So now what we have is -3 minus 16, which is the same thing as -3 plus a -16. Okay, so now a negative plus a negative is more negative, isn't it? So we end up with a -19, and that is our final answer. So hopefully you got that one right as well. And I will come back with one last problem, and then you get to do your homework. Here we have our last problem on this chapter. So I hope you've already done it and paused and did your practice. So now we've got this big old skeleton that we're going to have to take care of. And here are our substitution values. So negative cocoon, cocoon for those 2. And then we're going to change this to bracket. And then cocoon plus cocoon. And then bracket, change that one to a bracket, plus cocoon. Whew. All right, so now we have a lot to fill in. We know x, x, x. So x is the first one, which is a -4. And then we're going to skip 2, and x will be this one, which is a -4. And then lastly, this one, which is a -4. And A is a -2, and A goes into these two slots, -2, -2. Okay, so I often refer back to the original problem because it's less busy. So when I look up to the original problem, I can see, okay, I've got to do these right here first because they were in the original parentheses. So this is going to be where I'm going to start right here. And a -2 plus a -4 is a -6. So that was easy. So I've got a -6 inside that big bracket. So now I go back and I look and say, oh yes, that's this times this times this, because they're all right next to each other. So that's going to be a -4 times a -2 times a -6 times another lonely negative over here. So notice what I have. That's negative, and that's negative. Negative, 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 negative. I have 4 negatives. So I'm going to end it with a positive. And that positive is going to be what? 4 times 2 is 8, and 8 times 6 is 48. So positive 48, and then very end, plus a -4, and 48 plus a -4 is a 44, and we are done. Whew. That was a long one. And this is Mrs. A, and may God bless your day.